Hello and welcome. My name is Dave Cranen and I'll be your host for this tutorial. Once again, this tutorial is on NICET Level 3 Hydraulic Calculations, exam number 10014. These are the three design approaches we will be discussing. Area density method, room design method, special design method, and sorry, large drops, you didn't make the cut. We will also be discussing the following: early suppression fast response sprinklers, ESFRs, protection of stored plastic and rubber commodities, special occupancies, pressure considerations, frequently used formulas, commonly used tables, and of course, hydraulic calculations. The layout for a sprinkler system will be based on the following design considerations: classification of occupancies, water demand requirements, protection area per sprinkler, number of sprinklers needed, design area calculations, and the number of sprinklers per branch line. Table 11.2.3.1.2. This is a very important table to use and memorize. Figure 11.2.3.1.1 is our first hydraulic step. Section 11.2.3.2.2.1 applies to spray sprinklers only. Remember to increase the area of operation 30% for dry systems and 30% for slopes exceeding 1 in 6 units or 16.7% in non-storage applications. In an extra hazard occupancy utilizing high temperature sprinklers, the design area may be reduced by 25% for a given density, but this area cannot be less than 2,000 square feet. The annex explains that the order of calculations does not matter. The reduction can be applied first, or the increase can be applied first. Total number of sprinklers in the most remote or most demanding area shall never be less than 5 sprinklers. Figure A.22.4.4 is how we determine the number of sprinklers to be calculated in the most remote area. The room design method allows the designer to choose the room which is the most hydraulically demanding in terms of water supply and pressure. If a corridor is an appropriate choice for the design area when using the room design method, the number of calculated sprinklers can be limited to 5 if they are part of a single row of sprinklers. You can calculate a maximum of 3 sprinklers with a minimum discharge of 15 gallons per minute if the hazard is a building service chute serviced by a separate riser. For specific application control mode sprinklers, the design area shall be a rectangular area having a dimension parallel to the branch lines at least 1.2 times the square root of the area protected by the number of sprinklers to be included in the design area. Any fractional sprinkler shall be carried to the next highest. The design area for ESFR sprinklers must cover a minimum of 960 square feet. 12 sprinklers must be calculated, involving 4 sprinklers on each of the 3 branch lines, unless otherwise required by other sections in this standard. In preparation for performing calculations, know where the following tables and figures are in an NFPA 13 2016 edition. You need to know pressure and flow formulas, the Hazen-Williams formula, and the Hardy-Cross formula. Question number 1. What is the minimum discharge piping diameter for two 1,500 gallons per minute pumps? Answer number 1 is 3,000 gallons, 12-inch by 12-inch for common piping. Refer to page 20-20, table 4.26a. Question number 2. How do you convert head to PSI and PSI back to head? PSI is equal to head times 0.433. Head is equal to head times 2.31. Question number 3. How do you calculate the required quantity of water required for system demand stored in storage in a storage tank? The answer to question number 3 is you multiply the system demand in gallons per minute by the discharge duration. Question number 4. What is the difference in sprinkler discharge between a K 5.6, K 8.0, K 11.2? Per NFPA 13, page 13-28, table 6.2.3.1. The answer to question number 4 is K is equal to 5.6 is 100%, K8 is 140%, and K 11.2 is 200%. Reference NFPA 13, page 13-28, table 62.3.1. Question number 5. What commodity class are pharmaceuticals, aspirin, pills in plastic bottles stored in cartons? The answer to question number 5 is class 4. Reference page 13-304, A.5.0.6.3.4. Question number 6. What is the design criteria for a class 4 commodity stored 10 foot 6 inches high on pallets or solid piled with a roof deck of 30 feet? The answer to question number 6 is ordinary hazard group 2, which equals 0.20 times 1,500 square feet equals 300 gallons per minute plus 250 for hose flow, which will give us a total of 550 GPM total demand. Reference page 13-22 and page 13-259. Question 7. What is the design criteria for rubber tire storage stored on their tread 5 up to 12 feet high using standard spray sprinklers? The answer to question number 7. Refer to table 18.4a. Point 3 for control mode sprinklers, 0.3 GPM over 2,500 square feet, regardless of the sprinkler temperature. Question 8. Per NFPA 14, what is the total flow for a building 80 feet high having 4 Class 1 standpipes? Answer 8. 500 gallons per minute for the most remote 2.5 inch at 100 psi hose connections, and 250 GPM for the next 2 standpipes for a total of 1000 GPM. Question 9. An approved pressure regulating valve shall be used when the pressure at the standpipe hose connection exceeds what psi? The answer for question number 9 is 175 psi for 1.5 and 2.5 inch hose connections. Refer to NFPA 14, page 14-18, sections 7.2.31 and 7.2.3.2. Question 10. What is the minimum pipe size for a class 1 and 2 standpipe? Answer 10. 4 inch. Refer to page 14-19, 7.6.1.6 for combined systems and 7.6.2.